log x squared plus y minus log x, I mean log z.
Brilliant. Thank you. That's all I want you to realize. These two have to have positive because they come from a product. This cannot be expanded in any way. This is carved in stone. We have no property for log applied to a sum or a difference. So no one can simplify this in any way, shape, or form. Okay? Excellent. Thank you so much. So we looked at the product rule, we did a quotient rule. Next, number 3. Power rule or property. Log in any base of x or any quantity to a power rule. This power goes in front as a factor. Factor means multiplication. So please don't write a plus. It has to be a times log base b of x. Multiplication. A becomes a factor, which means multiplies log base b of x. So here is an example. So log base 7 of x plus y to the third power. What do you think about this? How will you apply the power rule here? And what should we write? It's okay if you're wrong.
3 log base 7
Yes.
x plus y?
Yes, when we say 3 log, we really mean exactly what you just said. Multiplication. Perfect. Awesome. Now, what if I want to condense? What if I have 2 log xy? How do I condense this? I don't want anything in front. So, of course, this also goes back and forth. So if I have a number in front of a log, I know it's nothing else but the power here of x. If it's a number plus, no. But if it's a number times, that is basically the power of the expression log is applied to. So here I have log of xy. It has to be in parentheses. To which power?
2.
Exactly. So please understand going back and forth. Number 4. Change of base. Formula. Change of base formula. The change of base formula is kind of redundant these days because of the calculator feature, but just in case. So let's say I want to determine log base b of x, and I'll show you with a calculator in a minute. And let's say I only have 2 options in the calculator. I either use log, which is common log, or I use natural log, which is natural log. So the options are log of the number over log of the previous base. Both have to be the same. You cannot swap. And this is natural log x over natural log b. So these two have to be the same log. These two have to be the same log. Log of x and log of the previous base. Okay? We know that this is going to be just one number. The number that we raise b to get x. So as an example, just give me any base you want. You cannot say 0, 1, or negative. Give me any base you want and any number you want to illustrate this. And how we check. 4, good. Of which number you want? Any number you want. Of course, it cannot be 0 or negative because log is not applied to those.
7.
You said 70?
Just 7.
7, perfect. Okay. So we know that this is a number. By the most important property here, can anyone give us the exponential equation for log base 4 of 7 equals something? How do I write the exponential equation? And remember, we always start with the base and we go counterclockwise.
4 to the power of y equals 7.
Good. Can anyone estimate this? Yeah, I can. It's definitely between 1, because 4 to the first power is 4, and 2, because 4 squared is 16. But can anyone solve this by hand? No. Not by hand. But if you say something like 3 to y equals 9, I would say, yeah, y equals 2. The point I'm making here is to show you how to eventually check. So we'll get to that in a minute. So I don't know how to find this, but I know the change of base formula. It doesn't matter which option I choose. This has to be a unique number. If I use this option, I'll get the same number. If I use this option, I'll get the absolute same number. Because there is only one number, I raise 4 to get 7, not 2 numbers or more. So let's use this, and I'll illustrate with both. So I have log base 4 of 7 equals log of the number over log of the previous base, or not both, but I will illustrate with both. Natural log 7 over natural log 4. One very important remark here. Notice this. Do not confuse it with this. This is log applied to a ratio. Careful. This is log divided by another log. Okay, so some of my students sometimes confuse this with this. This is a ratio of 2 logs. This is not a ratio of 2 logs. This is a ratio applied. This is a log applied to a ratio. So careful. So we're going to plug in the graphing calculator now. So I'm going to show, let me delete this. So we have log 7 and divide by log 4, which has to be exactly the same thing with natural log 7 divided by natural log 4. Absolutely, because there is only one number, we raise 4 to get 7. So the answer we got was y equals 1.403677.61. There is no need to copy all of them. I just wanted to. How do I check? Exactly how we wrote it here. 4 to the power. Close the, I always have to have parentheses. That's me. Second and answer. Because if I round that or truncate, if you want, the number or approximate the number, I will never get 7. But if I ask the calculator to use this ratio, not this number, when I click enter, I will get 7. If I don't get 7, then this number is incorrect. I missed something. Maybe I didn't put parentheses, or who knows. But here's what happens if you truncate the number. 1.404. I will never get 7. I either get a little bit over or I get a little bit below, depending on my rounding. But if I recall the previous answer, then I get the exact what I want. So I know that this is correct. Any questions so far? And you can say, but this is redundant, and I will have to agree, because we have in math, if you scroll up and you see log base, but you have to know the change of base formula. It's something useful. Okay, now if I have base 4 and I have of 7, and I'm done. I have to get this number. There is no question about it. So you have this feature in the calculator, and under math, go up. It's part A, log base, and it allows you to put the base you want. And you can say, why do I need a change of base formula? We didn't have this feature till recently. Okay? Good. Moving on to some other properties, and then we'll choose examples. Okay, so other properties, which page am I on? I'm on page 9. So we had the product, we had the ratio, we had the power, we had the change of base formula, number 5 now. Log base b of 1. And you can say, I have no idea what this means. Fine, no worries. We know it's y. We know how to write the equivalency, the exponential equation. Can anyone give us the exponential equation that replaces this log equation?
B to the power of y equals 1.
Excellent. So now let's give it a guess. What number should this be so that the answer is 1? Any number to which power is
0.
excellent. 0 except when a is 0. 0 raised to 0 is not 1. Please remember that. This is one of the indeterminate cases that you will talk about in calculus. So we know that, so the property 5 is that log base b of 1 is 0. Did we need to even think of that? No, because log in any base of 1 crosses the x-axis, right? Is 0. Log in any base of 1 is 0. Log in any base of 1 is 0. So that we know. Okay, property 6. Log base b of b. And you can say we have no clue, but we know how to change this into what? Anyone?
B to the power of y equals b.
Good, awesome. Thank you, Grace. Okay, so what is your assessment? What could y be?
Uh, 1.
Exactly, because this power must equal this power because they have the same base. So the only chance is 1. So here's property 6. Log in any base of the base itself is 1. Examples: common log of 10. How much will that be? Log base 2 of 2. How much will that be? Natural log e. How much will that be?
Log 10 is 10.
But this is base 10 here.
Oh. Oh, then it's
10, base 10.
100.
10, base 10.
It's 1.
Good. This one. Good. This one. I saw that, Sydney. Thank you. What about this one? Exactly. So log in any base of the base itself. Log base 10 of 10. Log base 2 of 2. Log base e of e. What if you forget? 10 raised to this power equals 10. 2 raised to this power equals 2. E raised to this power equals e. Feeling better about it? Yes? Okay, let's choose some problems now. Okay. No, that's not what I want. I want this. I want this. Let's see where I am at right now. Okay, good. Okay, so I think I'm almost there. So let's choose. I like to look at some expanding. Let's choose an example from 1 through 40, and an example from 41 through 70. So, you know, there is no need to do any of these. You can plug them in. You have the calculator and the change of base. Okay, so let's choose. I like to end today with any expanding and any condensing. As I said, only my phone says the correct time. Yes, we have 9 minutes. Plenty of time to look at a condensing and expanding.